Okay, welcome. This is big idea number 3, data and information. This is a set of practice questions that should help us prepare for the AP Computer Science Principles test coming up. Saying that some of the questions that we're about to see may be a little frustrating, and some of them have typos and some of them have some other kind of errors or a little dubious, and that's because this is a brand new test and some of the textbooks are trying to address questions that they anticipate will be there. So just keep that in mind as we go through, and let's not get too frustrated, but let's try and get some value from these questions. All right. Okie dokie. All right, so number one. Number one says, big data is more readily available today than it ever has been in the past. It's being created, accessed, and manipulated by professionals and amateurs alike. Which of the following statements below accurately describes the relationship between reading data and updating data? Okay, so let's take a look. So when we're reading data, we go into the database and we grab it and then we display it. When we update the data, we go into the database. We kind of have to save the field while we're updating it, and then it replaces that field, and then it might get rid of the temporary files. So that being said, there's going to be different storage requirements. So as we look through this, A says that reading data and updating data have the same storage requirements. Well, really updating, because of how I just described it, seems like it might have a little more intensive interaction with the database, and so storage might be a little more. So I'm not really feeling A. So B says that reading data requires less storage than updating data. So that's feeling a little more likely. C says there's no relationship between reading and updating data. Well, that's not true, because there is some kind of relationship. The size of what you're accessing and updating, if it's more than something else, then it's gonna be more overall as well. And D says that reading data requires more storage than updating. Well, that's not true. If you're reading it, you're just accessing and displaying it, whereas if you're updating, you're doing some more intensive processing when you're pulling that information, replacing that information, and setting aside the old stuff, and then removing those temporary files. So B is going to be the answer for number one. Okay, question number 2. Question number 2 says a school sports reporter has been given access to a data set of sports statistics that she is going to analyze for a research project. Which of the following types of software can she not use to organize and analyze the data? Well, spreadsheet software such as Excel, you can organize and analyze data. So that is not our answer, because we're asked for what can you not use. Web page software, well, that's just for displaying web pages. That's not any type of organizing or analyzing the data. So it's looking like B is our answer. And then database software such as MySQL or even Access, that's database software which is related to Excel. Those you can organize and analyze data. And the same with visualization software. So B is going to be our answer for number 2. Okay, question number 3. This is where it gets a little messy. So a librarian gathered data to analyze the ebooks that were borrowed from the library in the past 6 months. An ebook was listed in the data every time a book was borrowed. The following data was collected for each book. So they had the author, they had the title, and they had the genre. And it says the librarian wants to find the number of unique books read in the mystery genre. So the genre that they're looking for is the mystery genre, and they want to find the number of unique books read in that genre. Of the algorithms below, which can the librarian used to find the number of unique books read in the mystery genre. Select two answers. All right, so if they filter the data by creating a list of ebooks only in the mystery, so if they only get the mystery, that means that they're halfway there. And then if they sort the list of mystery books by title, so if they get all the titles in the mystery, and then go through, so iterate, go one by one through the sorted list, and then if an ebook is the same as the previous ebook on the list, then delete it from the list. So if it's the same as the previous, so the very first of the same book that keeps reappearing, the very first one is not going to be deleted. So that would leave you with a list of books that are all the same in the mystery genre. Especially if you then just find the size of that list, then that's giving you the number of unique books. So this is looking pretty good. The only reason why I don't like this too much is because when it says to iterate through the sorted list, and if a book is the same as the previous ebook. So this is my only kind of concern is, how do we know it's the same? Is it because the title's the same? Well, you could have books by different authors with the same title. So just because it has the same title doesn't mean it's the same book. And then also if it's the same author, doesn't mean it's the same book. However, this one is feeling pretty good because it says if the ebook is the same. So there's some determination that they're using to know that it's the same ebook. So A is good. However, we're told to choose two answers. Okay, so B, filter the data by creating a list of ebooks only in the mystery genre. So that's the same if I just choose a different color pen. That's the same as right here. So choose all the mystery books. And then sort the data by author, and then go through the list if the author of an ebook is the same of a previous author. So again, this is kind of what I was just talking about, is that if it has the same author, doesn't mean all the books are the same. So if we're just comparing the authors and not the names of the books as well, then that's not doing a good enough job. So B is not correct because it's going to get a list of only one book per author. It's going to get rid of all of the author's other books. Okay, so C, it says create a new list of data sorted by ebook title. So I'm going to write that over here, ebook title. So it's going to order everything by ebook title. And then it's going to iterate through the sorted list. So it's going to go through one by one. And every time an ebook is the same as a previous ebook, it says is the same as. So this is assuming ebook title being the same means that it's the same book, which isn't necessarily always the case. So I really don't like this question, but it is assuming that the same ebook title means that it is the same book. And it says delete the duplicate ebook from the list. And then set the counter to 0, and then iterate through the remaining list of ebooks. Each time mystery is listed, increment the counter by 1. So after it's got a list of unique ebook titles, it then goes through them, and every time the genre for the book is a mystery, so some of them might be mystery and some of them might be fiction, or some of them might be anything basically. So what it will do is every time it sees a mystery, it will then add one to the counter. So it's going to increment the counter by 1. So this also looks like it's possibly the correct answer, despite some of those other issues that I brought up. D says create a new list of data sorted by author. Go through the sorted list, iterate through it. Every time the author is the same as the previous, delete the duplicate author and accompanying data. Well, again, this is not really, we're assuming that every time you're an author, you only write one book. Well, that's not, most of the time it's not the case. So this cannot be the answer. So A and C would be our two choices for question number 3. Okay, so here's number 4. So it says, a football manager is preparing his roster for the new season. he has a database of players that include the following. And so names, jersey numbers, jersey sizes, position, age, and weight. All right, he wants to sort and filter the players in various ways for ordering supplies and for other game preparations. So in case they need to buy new jerseys, they have this information right there. It says he has 2 languages he would like to use. One is block-based. So block-based. And the other one is text-based. So block-based are programming languages that use the blocks that we've used in class, such as even like up here in the logo. This could be a Snap programming language, or it could be Scratch. These are a couple of them. There's others as well, but the block-based programming language is where we drag and drop and connect them all together. Text-based could be something like PHP, and many others as well. So it says he has a choice of either of these 2. So let's just think. It says which should he choose and why. So A is text-based because text-based languages are traditionally better with filtering and sorting data. So this at first glance seems reasonable. So it seems reasonable if we are a layperson. B says block-based because block-based languages are traditionally better with filtering and sorting. So now, not too sure, because here they are both giving us the reason of traditionally they are better. So these two were contrasting the block-based and the text-based, although both of them could achieve what he's wanting. So it all comes down to traditionally which one is better if we are looking at A and B. Let's keep going through our answers. C says either is acceptable, which is nice because just as discussed, either of them would work. And also in D, it says either of them is acceptable. And for C, it says either is acceptable because the numerical values associated with the data are small enough not to cause runtime exceptions. So here it's saying that the numbers are small enough, but how small is small enough? Also, how many players are on his team? We're not too sure. So this brings in another question mark right here. And then D says either option is acceptable because languages are nearly equivalent in terms of being able to express any algorithm. And this is true. Either of the block-based or the text-based, they can express any algorithm, and either option is acceptable. So I am tending towards this answer D right here. But again, it's not all that clear, but D seems to be the answer that fits the best. Okay, so question number 5. All right, so in order to get more students interested in art, the art professor is planning a trip, and the course will travel around the Northeast United States, exposing students to the works of these artists. The professor has access to a large database of museums that house various works. Okay, so this is a lot of reading. So far, we are up to here. Okay, the database includes the name of the artist. So artist, name. All right, what else does it include? The name of the piece, name. The type, so is it a sculpture or a painting? And the name of the museum. Museum, name. This is really important because this is telling you about the database and what it contains. So this is going to be important with the answers that are to come. Let's just make sure we've got everything. So the database includes the name of the artist, the name of the piece, the type of the piece, the name of the museum. Okay, it says if the professor wants to ensure that students are exposed to the maximum number of works from each artist. So the maximum works from each artist. So really this is maximum number of works and maximum number of pieces. Okay, maximize this from each artist. How should they build their query of the database? Okay, and also keep in mind that he's planning a week-long course on the road, and the course will travel around the Northeast. So this is going from museum to museum. Okay, so for option A, we're told that the professor should run a query that returns a ranked, which means ordered, ranked list from first place onwards of the total number of pieces from the 4 artists at each museum. So Museum 1, Museum 2, Museum 3, and so on. And it's going to take the 4 artists and it's going to be a ranked list of the total number of pieces. The total from the 4 artists at each. So this is pretty much what we're getting. This is a representation of that. And then it says the professor then can then query that data. So can query the total pieces at each to create an ordered list of the names of each work by artist and museum. Okay, and they can then determine which museums have the most unique set of works from all 4 artists. So that kind of seems reasonable. Let's just go right into the middle. The professor can then query to create an ordered list. So an ordered list from each of the names of each work by artist and museum. Names of work by artist and by museum. So A is looking pretty good. A seems like it addresses all of that. Let's go down, just take another look at some of these others. It says a professor should run a query that returns a ranked list of the total number of pieces from each of the 4 artists. That's good so far. And then it says a professor then query the data to create an ordered list of how many works are at each museum by artist. Now, this isn't the thing that's different here is that at each museum, here it says the professor can then query that data to create an ordered list of how many works each museum, each artist. Whereas up here it says the names of each work, not just how many works, but the names of each work by artist and by museum. So these are very, very close, but A has more detail, and it seems to address this question: how should they build their query in terms of exposing to ensure that the students are exposed to the maximum number of works from each artist. So let's keep going, look through C and D. So C says they should run a query that returns a list of the total number of pieces from the 4 artists at each museum. So this is looking good even though it's not ranked. And it says the professor can then query that data to generate a travel itinerary based on the proximity. Well, proximity is looking at location. And up here, there is nothing to suggest location inside this data, inside the database. Even though we could find the location based on the name, this itself is not possible with the information that we're given. And the same with D. It says the data can then be queried to generate a report that matches the list of works to the locations of the museum. So this bit here is problematic. So A and B are very close in their descriptions. A has a little more detail, and I'm tending towards A, but just keep in mind again that some of these questions I believe are not constructed as well as they could be. But I'm going to go for A for question 5. Okay, question number 6. Okay, so I believe this is another slightly frustrating question as well. So a movie streaming site, so immediately we might think about Netflix, collects the following data from all of its subscribers. Okay, so it has the geolocation of the viewer. Okay, so it knows where you are. Has the user device information. So it knows if you're on a cell phone or if you're on an iPad or a desktop or direct to TV. It knows the time of the day or night that the content is being accessed. Okay, fair enough. It knows when the user pauses and restarts the content. Okay. It says based on this data alone, which is going to create a problem for us in a minute, but it says based on this data alone, which of the following is not true? Assume that there are not multiple user profiles available. So assume there's only a single login to each of these websites. All right, so A, it says the site might make different recommendations when you log in on your laptop versus when you log in on your tablet. Well, is this possible? And we are looking for which are not true. So is this possible? Well, it does know if you're on a tablet or a laptop, so it could make different recommendations. So this is possible. And so is it not true? Well, no, it's not necessarily not true. Okay, B, the site knows precisely how many people are watching content at a given location. Well, if you have one Netflix account, your whole family could be watching, maybe 3-4 people, maybe more, and Netflix wouldn't know how many people are watching from your one account. So this is not true that they know this. So B is going to be our answer. Now, that all seems reasonable, but if we keep reading, the site can determine the point during which content viewing when the user is likely to navigate away from the site and offer suggestions for different content. Well, it does collect data based on when the user pauses and restarts the content. So pausing, is that necessarily navigating away from the site? Well, it's possible. But still, a pause doesn't necessarily mean you're navigating away, and restarting doesn't necessarily mean that. But I think they're kind of implying that they are collecting that information here when the user pauses. So even though I don't like it completely, I think I'm going to eliminate this because the information tends to match. Okay, and then D, the site can determine that TV shows are watched during the week while movies are watched on the weekends. So during the week, Monday to Friday, weekends, Saturday, Sunday. So this one, I believe, cannot be true based on this data alone because of these 4 bits of data. Even the third bit, the time of the day and night does not include the day. It just knows the time of the day or night. So therefore, really, this one should also be circled. So it looks like there's 2 answers. However, from the answer sheet, they are going with B. Whereas I really don't like it because they should have included day in the data that they were collecting. And they shouldn't have scared us by saying based on this data alone, which means that we would ignore day and we wouldn't assume that they were collecting it. So B and D seem to be the 2 answers. However, the textbook is demanding B. So that was question number 6. Okay, 7. Okay, so when scientists make discoveries, the expectation of the scientific community is that they share their data with their peers. Okay, so we're kind of told this as fact, so that their findings can be recreated and verified. Okay. However, that is often easier said than done. Which of the following is not a reason why scientists may be unable to share their data? So first of all, not really happy with the double negative here. Not a reason why scientists may be unable. So in interpreting this, sometimes scientists So sometimes scientists are unable to share. So our big question is why, and also specifically why not. All right, so now that we frame that, let's look at A. Much of the scientific data is not in digital format, and the originating scientist has no responsibility to digitize it for peer review. Well, if we take as fact that the expectation of the scientific community is that they share their data with peers, if that truly is the expectation, and that's what they've told us, then they do have some kind of a responsibility to share. So this becomes, do we think that much of the scientific data is not in digital format? And this is hard to believe in this day and age, that much of their data is not in digital format. And so I believe that this is not a reason as to why they are unable to share. So straight away I would go for A as the reason, as to not a reason why they may be unable to share. If we keep going through the rest, there is no central storage space where data can be kept and easily accessed. Well, that's possibly true, right? So that could be a reason why they are unable to share, because there's no centralized place. C, for many fields, there is no uniform methodology for how to record and describe the data. Well, that's possible. There could be different methodologies, and we might not know which is which, so that's possible, I guess. And then D, oftentimes scientists overlook the need to include metadata in the data that they make available. So metadata isn't necessarily the content or the findings themselves, but it's all of the attributes, which could include the time of day, the collection information attributes, the tools that they used, all of the metadata that that supplements the content and frames the content. So I guess that could be true. That's possible. So A is the standout for me, as though something that is something that is not a reason. Okay, for question number 8. All right, so all file types include some sort of metadata. Which of the following accurately describes the metadata that might be found in each file type? So a digital image. So the size of the image. Okay, yeah, that could be part of the metadata. Color depth. Okay, resolution. Okay, the date when it was created. Yep. The location where it was created, where the image was taken, the photo was taken. Yep, all of that seems like might be found in the file type. Okay, 2, text document, the content in the document. Well, however, the content in the document is not specified as the metadata itself. Copy of the file, other content imported into a document. So this is a little sketchy. It's not really looking good. So 2 we're going to cross out. And in fact, because we know 1 is true and 2 is not true, we know it has to be C. And if we just take one more look, the web page, the description of the page content, the keywords that reference the content and assist in web searches. So that's all metadata. That's at the top of the HTML. So that does work. So for number 8, we're going to go with C, which is 1 and 3 only. Okay, so question number 9 gives us these 4 terms at the bottom. And so knowing what these mean is kind of the key to answering this question. And it says, in the educational world, teachers give data and information, and students process it. So students process it to get knowledge. And in the digital world, there's search engines, wiki pages, and the like that provide access to information that people can use to gain knowledge. So gaining knowledge, right? So gain knowledge. That's what this is about. And then it says, even in our daily lives, we take in data and information and convert it into knowledge. The field is new and growing. What is it called when we transform this data and information into knowledge? Well, one thing that jumps out at me is alchemy. And this word down at the bottom, alchemy, means the transforming of matter. And this is used in chemistry, like alchemist or alchemy. So information alchemy is the transforming of information into knowledge. And so D would be our answer for number 9. Okay, moving on, number 10. Okay, so number 10. It says the digital landscape has made large data sets more accessible than they ever have been before. Data is the most valuable resource for researchers. So right here, data is the most valuable resource for researchers. And the sheer amount of it is changing the way research is done. While big data is often seen as positive, researchers must be very wary of some aspects of it. So this is about how researchers are wary of some aspects of big data. Which of the following are challenges for researchers working with big data? So number 1, the collection of data is more important than how the researcher is going to use it. Well, first instinct is to say that, well, everything's important. But in the situation with big data, because the methodologies of how it's all collected and different data sets could be different, the collection of data is actually a bigger issue than how the researcher is going to use it. So, this is something that stands out to me as one of the challenges. So I'm going to circle that. Okay, next, because of the amounts of data present, many researchers look for trends that support their hypotheses rather than let the data lead them. So I'm guessing that this is kind of possible, right? With the sheer amount of data, maybe they have their hypothesis and then they look to see if the data could match their hypothesis. And so they might be led rather than letting the data lead them. All right, so I'm going to circle this one as well. Number 3, it says large data sets require special analytical tools, servers and other equipment that some researchers may not have and or may not realize they need to use. So yeah, there might be limitations with servers and equipment. Large data sets require additional resources for tiny data sets. So this is also important. Number 4, it says new computational techniques are not keeping up with the growing number and size of data sets available. Well, this I kind of disagree with, because there's new techniques, but also they are keeping up with the growing number and size of the data sets that are available. So I think that they are both increasing together. So this one I'm going to put a little question mark with. I don't think that this is necessarily, these are like a challenge for those researchers. And 5, large data sets usually come from multiple sources, which means that collection techniques may have differed. So that's kind of what I was mentioning in connection with the first one up here. A researcher not taking this into consideration may come to incorrect conclusions. So 5 I'm also thinking is correct. So if we can discount 4, then we discount all of the above. And this leaves us with 1, 2, 3, and 5. So that would be B.